Alright guys, last day of the module here, day 4, and we're going to be learning about the time value of money here in part 1, interest rates and the time value of money, and then different places to save your money. And so this is going to be chapter 2, section 2.6. We're going to go back a few chapters for the time value of money, but then we're going to jump ahead to chapter 4. We're going to do 4.1 and 4.5 only from that chapter. And so to work on this, you're going to need your financial calculator, whatever you picked up, because we're going to use that heavily through the time value of money section. We won't do a workshop in that section, but we'll do a workshop after part 2. And this is what the workshop looks like. We're going to be thinking about you having $2,000 and different places to save it, and you're going to use your new talent for computing the future value of savings to figure out which one of these options would be the best for you. Alright, so as always, you come into Georgia View, and right over in our module, you'll find day 4. I wanted to point you towards something though. Not only do we have the reading and the lecture and the workshop to do, but you have a little bit of homework and your last discussion board opportunity. But I've loaded up a sample quest for you to see kind of what to expect on the quest for tomorrow, and to use as you study for your quest. And so you probably saw it. It's sitting right here in the main day 4 folder. One thing I'll say about the quest tomorrow is that you should focus on studying the material in the lectures. All of the slides that I post when I write the quest, I go through my slide notes, and that's where I get my questions from. So I don't get them necessarily from the book's question bank. Some of the questions you get on your homework are a bit broader or different than what I think I would like to ask you about. You really want to focus on the workshops and the material in the lectures for the quests on Friday. All right, let's get going. So we're going to start off thinking about savings by thinking about how banks earn money. So think to yourself, how do banks earn money? Well, the simplest answer is that they charge interest rates when they loan out money. So if you need a car loan or you need a mortgage, you probably get it from a bank somewhere. And so these banks charge interest, and that's how they make money. But then that begs the question, where do banks get the money to lend it out? They don't print it themselves. So how do they get money to lend out to begin with? Well, they're going to get that money from savers like you and me. So when we put money into a bank, we save it there for our use at a later date. Banks don't let it just sit there in their vaults. They use it. They lend it out. They buy other investments. And so they try to earn money off of the money we put in the banks for them. And so I want to ask you one more question. How do banks entice us to put money into savings? Hopefully you're thinking about interest rates. So in order to get me to put money into a savings account for any meaningful amount of time, banks will pay me a little bit of interest. And that's kind of where this chapter starts, is where do we look to earn interest on our savings? I pulled down several different types of options of places to put your money and their interest rates. And I did this last May, I think. This is current as of a year ago. And one thing you'll notice, and I have a few lessons about interest rates as we go through this. The first lesson is that the longer you agree to leave your money with the bank, the higher interest they'll pay you. So if you look at cash doesn't earn any interest, it's in your pocket. Checking accounts will earn a modest interest rate. Savings accounts, however, will earn a little bit more than checking. And certificates of deposit, we'll talk about these later, they require even longer time commitments, and they pay a higher rate. So lesson number one is that banks are going to pay you a higher rate the longer you agree to leave your money there. And the reason why they'll pay you this higher rate is because they don't have to worry about you taking it out or wanting it, right? Demanding your money when they've already lent it out and can't give it to you. So interest rates tend to be larger for larger time commitments. And then the second thing I want you to note is that these rates are tiny. And the reason why that might be, why are these rates so tiny, is that we're still kind of recovering from a recession. So whenever the economy is struggling, the Federal Reserve keeps rates low because they want consumers to borrow and spend money. And if the interest rate's really low on loans, you'll borrow, and you might buy a car. Same thing with corporations. If they have the opportunity to invest in new machines, they're going to do it when the interest rates are lowest and they can borrow really cheaply. And so that's good for borrowing if you need to borrow, but that's not very good for saving. And that's where we're at right now. If we look at 5 and 10-year nominal interest rates on treasuries, they're quite low. The same thing can be said for your commercial bank certificates of deposits. We look at what the CD rates were, and then we come down to our big recession, and they're almost zero for a certificate of deposit. I'll get into more on the savings vehicles here shortly, but before then, we're going to talk about how interest rates work. So this gets into time value of money calculations. The first thing to look at when you're thinking about how to use interest is the types of investments that you're making. And the first type you can make is a single sum. This is when you put one lump sum of money into the bank. You don't take anything out, you don't add anything in, and you see how it grows. And the other is an annuity. And this one is more like saving for retirement. You're going to make level payments to yourself into this savings account, and it's going to earn interest all the way into some big sum. And so the difference here is single sum, you put it in at the beginning and you leave it alone. Annuity is you put some in the beginning and the next year and the next year and the next year, and so you have periodic savings. Second way to categorize time value of money calculations is by what you're trying to solve for. So if you're thinking about saving for retirement, you're going to be thinking about a future value calculation. And you're going to ask yourself, how much is a dollar today worth in the future if I invest it? You want to solve for that future value of a dollar. However, there's also present value calculations where you ask the question, how much is a dollar earned in the future worth today? And so this seems like a really weird one. Like, why would I ever need to know how much something down the road is worth today when I'm living in the present? Well, this really helps when we have two different investments that are going to pay us different amounts going into the future. We got to compare them, and so one way to do that is to take the present value of all of those future payments, and whichever one has the largest present value is the better deal. These things will make more sense as we do examples going forward. So, the last thing we want to be familiar with is why interest is such a big deal. Is because interest can be compounded. And when I say compounded, there are rules that tell us how often the interest earned on our investment is added back to the principal. And so if you're unfamiliar with those terms, the principal is the initial balance that you put into the account. And as interest is added to the principal grows. So let's do an example. Say you have a $1,000 investment and it's going to earn 4%, and we're going to compound it annually, which means every year we'll take the interest, add it to the principal. So in year one, your $1,000 grows by $40. Compounding annually means we're going to take that $40 at the end of the year and add it back to the principal, so that in year two, the interest is computed on itself. So $1,040, our interest is now earning interest, and so the interest earned in the second period is greater than that in the first period, we earn $41.60 in the second period instead of 40. So our ending balance at the end of year 2 is $1,081.60. Now, if we didn't have compounding interest, we would have what's called simple interest, and we would earn $40, and then the next year the $1,000 principal would earn $40 again, but we wouldn't be earning interest on interest, and so we see how the ending balances are much smaller when we don't have compounding. So compounding is going to be really important for us, and we're going to pay attention to the compounding rules that come with the different investment vehicles we're studying. So get your calculators ready, because I think that it would benefit you a great deal to run through these calculations with me as I'm doing them. So I want you to think about this sentence. I want you to answer, is this a single sum or an annuity calculation? Is it a present value or future value calculation? And what is the compounding rule? So give it a try. Maybe pause the video while you figure that out. What we know is that this is a present value calculation. How much money do I have to save today to buy a $200,000 condominium in 8 years? So there's not payments going on, just a single lump sum in the beginning, and we're wondering, what is that value? Well, the single sum present value is going to be what I need to put down today to add up to $200,000. So let's solve this. And so I'm going to teach you how to use your financial calculator. But if you need help and you're confused about anything with the calculator, Appendix E in the book can help you get up to speed. So check that out if this is confusing. What I like to do when I'm doing time value of money calculations is draw a timeline. And so this is an 8-year investment. So I draw 1, 2, 3, all the way up to 8 bars, 8 years. This is today. This is 8 years in the future. And so my question says, I need $200,000 in the future. So I put that as my future value, $200,000. My question is, how much do I have to save today? That's what I'm solving for. And the last bit of information I need is my interest rate, which is 5%. I'm told that it's compounded annually, which means every year that interest is going to add back into the principal and build upon itself. The calculator is going to do this for us, though. The way we work the calculator keystrokes is to put the input, which is the value, and then what variable we want to assign it to. The variable we want to solve for, we'll press the compute button first, and then the variable that we're solving for. So if you look on your calculator, your compute button is probably located on the top left corner. For this particular problem, we would enter $200,000 for our future value. So we would press 200,000 in the calculator and then press FV. And you'll notice that FV will pop up on the screen and it will show that it's stored that amount. The next button we will press is 5 for the interest rate, and we'll push the I over Y button to store that in our interest rate. 8 periods, we'll press that button, 8, and then press N to store it as the number of periods. And then if we press compute and present value, the calculator will spit out how much we will need to invest at time 0 to have $200,000 in 8 years. You'll notice that this number is negative. And it's negative because it's a cash outflow. This investment is coming out of your pocket, so it's a subtraction. But the future value, which is money that comes back to you, is positive. So remember this, whenever you're putting in values that are coming out of your pocket or solving for those values, they're going to be negative. So let's do one more example to see if you can get it on your own. Here we have an 8-year investment again, and I'm asking if I invest $35,000 at a fixed interest rate of 3.5% annually, how much will I have at the end of 8 years? You see how the timeline has changed. Now I'm asking if I invest $35,000 today at 3.5 interest, compounded annually, what will it be in 8 years? So pause the video and see if you can get an answer in your calculator before I give you one. Okay, the keystrokes look like this. Negative 35,000, because you're paying that into the bank account out of your pocket, or to the investment out of your pocket. 3.5 is the interest rate. 8 is the number of periods, and then we'll compute the future value. We should see that this number grows to a sizable $95,248.57. The number is positive because it's a cash inflow to you, but the present value we put in was negative. And so what's interesting is that if we just invested $35,000 underneath our mattress, cancel that. Scratch that thought. That's for the next slide. Okay, so that was a single sum, and now it's time to think about annuities. So look at this question and see how it differs. How much money do I have to save each year to buy a $200,000 condominium in 8 years? So I want to back up to that first question. This single sum question said, how much do I have to save today? One lump sum to make $200,000 in 8 years. This question is more realistic. How much do I need to save each year to buy a $200,000 condo in 8 years? And this is annuity, because every year we're going to be saving something. So the timeline looks a bit different. Here you'll see, with an annuity, we're starting out with $0. Rather than putting a lump sum at 0, we're going to start out with 0. And then at the end of each year, we're going to make a payment into the account. And so you may notice on your calculator that there actually is a payment button, and we're going to utilize it. Payments each year, even on the last year, all adding up to $200,000. Same interest rate as before. So what's going to get us there? Well, here's how it's going to work. We'll put a 0 for our present value by pressing 0 and then the present value to store it. 5% interest rate by pressing 5 and press I over Y to store it. 8 N to store it. $200,000 is our future value, and then we're going to press compute and payment. You should have gotten negative $20,944.36. Why is this number negative? Again, this is incorrect here, but the number is negative because it's a cash outflow from your pocket. And so what I want to mention is if you didn't get that number, your calculator might not be set in end mode, which means it's not considering the payments happening at the end of each period. And that's an easy fix. If you have the financial calculator I mentioned in my syllabus, you'll simply click second button, it's beige or yellow, and click payment. And you'll notice how above the payment button there's a 3 letters BGN. Your calculator is probably set to begin. So if you press second and the payment key and your screen reads end, everything's good and you should have gotten the right answer. So try it again if you got it wrong. If your screen reads begin, you need to change it. So you press second again and the enter key, and that should change your calculator to say end, and you'll be set up to solve this problem. Okay, let's try one on your own. How much money do I have to save each year for a $15,000 down payment on a house in 5 years if the interest rate is 4.7%? So, my poor grammar aside in that sentence, what does it sound like we're trying to do here? We're trying to save for 5 years, every year, to have $15,000 to pay towards a house at the end of the 5 years. Pause the video and see if you can figure it out on your own. Okay, here's what you should have got. Press 0 for present value, 4.7 and then interest rate, 5 and then N, and then $15,000 for your future value, and compute the payment. You got $2,730.94. You did this correctly. Now, one thing that you're going to see in reality that is a bit different than what we just studied is that interest rates are always stated as annual rates, but they're often compounded more frequently. So you might think of a credit card's annual percentage rate might be stated something like 12%, but your payments don't gather interest annually. They actually gather it much more frequently than that. So APRs have a rather interesting compounding rule that we'll study later on in this class. For now, let's consider a very simple example. We have two investments. And so we're trying to figure out which would you rather have for $1,000 single sum investment. You have a 5% interest rate that's compounded annually, or a 5% interest rate, 5% annual interest rate compounded monthly. So I'm going to change this so we don't have confusion. There we go. You have a 5% annual interest rate or a 5% annual interest rate compounded monthly, so a different compounding rule. What is the future value of option A? Well, you already know how to do this. It's a single sum, $1,000 invested for 5 years at 5% annually. So if you want to practice your single sum time value money calculation, pause the video now and see if you can solve for that future value. You should have gotten $1,276.28. Now we're going to study the impact of the different compounding rule. So if the rate is annual, but it's compounded monthly, we have to convert the rate to a monthly rate before we do the calculation. See, this rate works out in the previous example because interest was compounded annually and the interest rate was an annual rate. However, now we're going to compound every month within a year. So the interest rate stated at an annual rate is incorrect. And the way we adjust this is with the following keystrokes. Present value is still the same, negative $1,000 coming out of our pocket. This is not an annuity, so we're going to set our payment to 0. It's a single sum. But look at the adjustment we make here. Instead of just putting 5 for the annual interest rate, we're going to divide by 12 to make it a monthly interest rate, because there are 12 months in the year. So we divide the annual interest rate to make it a periodic interest rate, so that it is a monthly interest rate and not an annual interest rate. 5 over 12, solve it, and then hit I over Y. And so you should be putting 0.4167 into your interest rate. However, we have a monthly interest rate. We need to have months as the number of periods. So there's not just 5 months in 5 years. There's 5 times 12 months. So we need to put 60 in for our number of periods. If you do these things and then compute the future value, you'll get $1,283.36. So let's compare the two options now. Future value of the 5% annual was $1,276.28. The future value of the 5% annual interest rate compounded monthly was $1,283.36. And so when we compare these, and not only these, but any other type of investment that might differ greatly, we can think about computing this helpful statistic here called the effective rate of interest, or the effective interest rate. And the ERI is very simply the interest earned over the period divided by the initial investment. So in this case, the effective interest rate for the A option would be the $276 of interest we gained divided by 1,000, a 2.76% gain because of interest. However, compounding more frequently, we see that our effective rate of interest was 2.83%. So what this suggests, and it's true, when it comes to saving, having more frequent compounding periods adds a higher effective interest rate. Now, as you can imagine, we'll talk about loans later, but as you can imagine, whereas you would want frequent compounding with savings, you don't want frequent compounding with debt, because if you're making loan payments, that means the interest is going to be a lot higher on your loan than what it appears. but we'll study that later. And there's what I said. More frequent annual rate is compounded, the higher the effective interest rate. All right, so that's the end of part one, which was about time value money. And we're going to move on to part two. We don't have a workshop for part one, but what I do want to give you is some practice problems so you can try out some more time value money stuff with answers. There are some on the homework, but these are low-cost ways to test what you've learned. So in the back of the chapter, for chapter 2, in the financial planning exercises, question 5 has 4 parts, and here are the solutions if you'd like to give those a try. All right, so now let's think about where to put our money. And it may seem pretty obvious to you, the difference between a checking and a savings account, but it's worth thinking about, at least intuitively, what the differences are. Checking accounts are often called demand deposits, and they most of the time don't even come with an interest rate. If they do, it's very small. And that's because the banks anticipate you not keeping money in these accounts. And so if you're constantly moving money into and out of your checking account, they can never rely on it being there, and they can never take it to go make money off of it. So they're not going to offer you anything to keep it in the account. Whereas savings accounts are often referred to as time deposits. This is because you're expected to keep money in a savings account for a specified period of time. So your savings account will often bear an interest rate when your checking does not, or a higher interest rate when your checking does. And one other thing that banks might try to do to discourage you from pulling money out of your savings account is put limits on how often you can pull money out of your savings account. And this is to help them gauge how much money they have at a given time to lend out and make money off of. But beyond savings, we might want to think about some better ways to try to earn interest. Now, as I showed earlier on in this lecture, interest rates are pretty low across the board for savings, period. But one thing you might look at traditionally at banks, at your local bank, is a certificate of deposit, or a CD. And so these all have a fixed period. You can buy 1, 2, 3-year short-term CDs. You can even buy longer-term, like 10-year CDs. And these things are really commitment devices for consumers because they have pretty steep early withdrawal penalties. So you put your money in there for a fixed period, and they're going to charge you a big fee if you try to pull it out. The good thing about this type of investment is there's no risk. The bank is FDIC protected, which means they're insured by the federal government from default. So if anything ever went wrong with the bank, your money would still be available. And you can use these in periods when rates are falling to earn a fixed rate on your savings. The next level up is a U.S. Treasury bill, and these are basically equally risk-free to like CDs. These are debt securities issued by the U.S. Treasury, and so the government has to operate, and so one of the ways it does this is by raising funds through selling their own securities to consumers. And so one type of these is called Treasury bills, or T-bills. And so I'll talk about this second part here in a minute about how they're sold and priced. But for now, you can buy T-bills only up into a year in duration. So I could buy one that I cash in 4 weeks, all the way up to I could buy one that I cash in a year. What do you think, given what we've learned so far? Which of these has the lowest interest rate? The 52-week or the 4-week? Well, let's check it out. We can view the prices of these at treasurydirect.gov. And so here's a list of the most recent transactions. And we see the 4-week transaction has an effective rate of interest of 0.735%. So that's not 73.5. That is 0.735%. Not a very big yield on your investment there. Whereas the 52-week Treasury bill has a 1.083%, still a quite tiny effective rate of interest on your savings, but higher the longer you agree to lend the money to the U.S. government. Some other advantages, well, you can buy these every Monday at treasurydirect.gov, but they have no state or local income tax. And that's going to be true of every federal savings bond, is that they're not going to be taxed at the state or local level. Different levels of government don't believe in taxing the incomes of each other. So what does it mean to be sold at a discount? Well, savings bonds are sold on a discount basis. What that means is you'll see a price for the bond, which is somewhere around $98, and a par value, which is what you'll turn it in for at maturity. So these are fixed. They're not a rate of interest like you would see on, I suppose, like a corporate bond. So on an investment where you bought $1,000 worth of treasury bills that you paid $980 for, you could sell them for $1,000 at maturity and make $20 of interest. So here's a quiz. What's the effective rate of interest on the $980 of T-bills that you bought? See if you can figure it out. Pause the video. Okay, the effective rate of interest is the interest earned, which is $20 over our initial investment, which was $980. So we earned 2% on this transaction. We can verify this if you want to. Look over here at the 52-week Treasury that gained 1.083 effective rate of interest. When you click in for more information on these bills, you can see their issue date, and when they will mature, 1 year. And you'll see that these things sell. This one sold for $98 and almost 93 cents. It will be cashed in a year at $100. And so the difference there is $1.07. And so if you run it really quickly, $1.07 over 98, 93, that's 1.08%. So that's where they're getting these interest rate measures from, is effective rate of interest. Historically, Treasury rates used to be pretty good. What we're showing here is over time, the rates that you could earn on a 2-year Treasury bill and a 10-year Treasury bill. So they used to be quite high, around 4 and 5%, until about 2008. And now our 2-year, our very short-term Treasury bonds rates are quite low, less than 1%. And then the 10 years are up around 2%, but you have to invest 10 years just to get a 2% yield. And inflation is potentially outpacing that. So the last thing I want to show you is Series EE bonds. These are your longer-term savings bonds from the U.S. government, and they're a little quirky. So they're 30 years max bonds, but they reach their maturity at 20 years. And so the way this works is you buy the bond at 50% of its face value, and in 20 years, it's guaranteed to double. So whatever you bought it at, guaranteed to double in 20 years. However, along the way, it has a fixed interest rate. And so that interest rate may or may not get you to 20 years, or to double in 20 years. But the idea is after 10 years, the rate can be changing, and you can also sell the Treasury along the way as well. These bonds must be held at least 1 year before being sold, or you'll reach a penalty. And what's interesting is that Series EE bonds come with this provision that if you use them for educational purposes, you can avoid taxation on the income that you get from them when they double in face value. And so we can take a look at these Series EE bonds. There's a page that describes what's going on. Currently, the fixed rate is quite low at 0.1%. And so that was set October, or it's going to be reset again in November. And we see that you can buy up to $10,000. So that Treasury, that Series EE bond would double to what? Well, it would double to $20,000. And here's the information that I just talked about. So you have to hold them for at least a year. They can earn interest for 30 years. They're guaranteed to double in 20 years. And so that is all I have to show you from chapters 2.6 and chapter 4.1 and 4.5. But let's take a look at, the rates are poor. Let's take a look at the workshop. So this is what you'll be doing now that you've learned a little bit about these savings vehicles. I want you to find a bank near you, find the interest rate and compounding rule they use on their savings account, and figure out if you put $2,000 in there in 5 years, what would that be? Figure out the effective rate of interest. Do the same thing for a 5-year CD. You can pick the same bank if you like. This question is harder. So there's no such thing as a 5-year treasury bill, but you can buy 52-week ones for 5 years. So what I want you to think about is what can you do at the end of each year once these things are cashed in. And the last thing is you can look for a 5-year, or you can look for a Series EE bond and see what happens, what it would be if you sell it at the interest rate they give you after 5 years. So see what you can do with that. There's some questions to answer about what you find out. And don't forget to upload this to the assignments folder in Georgia View. All right, that's it. Have a good Thursday.